In the same business or different, complementary inventions, really. Bernie.
Hi guys. Obviously, first question, Justin, have you put Ian's house through the specs and how would it go?
We haven't given that a go yet, but we're discussing that.
The kinds of features that he's got, that he's really highlighting there, are they the same sorts of things that you'd be looking at?
Exactly, and it's looking at the landscaping and the design as one complete system of interaction.
Okay, great. Now, Ian, with your house, I know you've said that it's about degrees of confidence, but especially after the Victorian bushfires this year, the last thing we want to be doing is giving people false hope that their house is going to save them. What kind of testing have you done to really work out where the line is in how much protection the house can afford?
Well, the important thing, I think, to say from the outset is that this house is not in an officially recognised bushfire prone landscape. So it uses certain elements like the fire shutters, for example, and fire-resistant glazing and fibre cement sheet, which have been tested and by organisations such as the CSIRO, and they've been proven to perform in this instance.
And Justin, because we do actually, through this hideous experiment that happened in Victoria earlier this year, we have got all this information now about exactly what structures were affected in which ways and which survived and didn't. Have you used that to check the validity of your site sketcher?
So we're deliberately collecting the data from these fires, which is quite a time-consuming process, but we're collecting it in a particular way that can allow us to validate and improve the algorithms and assumptions behind this model.
James.
I think the other interesting thing is you're matching the house to the environment rather than the other way around.
Yeah.
How much extra cost does that actually put on a structure?
Well, as an architect, you're rationalising a whole lot of different objectives. I think it's fair to say that bushfire responsive design was put at a very high priority in this house. Having a simple geometry actually makes a lot of sense for keeping costs down and for reducing exposure or likelihood of ember intrusion into a building.
Mark, Justin, let me ask you now, you take a look at the outside of the house, is there anything that you might be overlooking that's inside and is unavailable to the site sketcher that might affect the fire safety worth of a house?
Sure. Well, in analysing the envelope, we're looking at the materials, the collection points, but also the gaps. And when we find gaps, we instantly need to know what's behind the gap and what's the likelihood of whether an ember passes through this gap. Is it into the roof space? Is the roof space combustible? Is it into an enclosed or unenclosed subfloor space? Is it actually into the occupied space within the structure itself? And given those different observations, we can make assumptions about the likelihood of those embers igniting and developing into a structural fire, which causes the intensity that we see.
Summing up, Benny.
Look, you guys have obviously sorted out the problem for houses that are yet to be built, but if we can find a way of putting those ideas into existing homes to make them more fireproof, then I think we're really onto a renovation craze worth funding.
Look, these inventions go hand in hand. I think a combination of better modelling and better design will surely make our houses safer. Well done.
We need a comprehensive revolution in design for fire safety in the bush. What Ian's doing in design and what Justin is doing with simulation work hand in hand to help us produce the next level of buildings that we're going to need.
Yeah, thanks a lot, guys, and good luck with your work.